rate constant or specific reaction rate. The ordinary form of rate equation is R is equal to K into A power X into B power Y. Here the constant K is called as the rate constant. When concentration of the reactant A and reactant B is equal to 1 mole per liter, then the equation becomes R equal to K. So, rate constant will become equal to the rate of reaction when concentration of all the reactants in the reaction becomes equal to 1 mole per liter. This gives the definition for rate constant. So, the rate constant is defined as the rate of reaction when concentration of the reactants are unity. The rate constant is also known as specific reaction rate and is represented by small letter k. Now let us see the unit of the rate constant. The general form of rate law is R is equal to K into R power N. R is called the rate, K is the rate constant, R represents the reactants and N represents the order of the reaction. K is equal to R by R power N. R, the rate, has the unit mole per liter per second. Concentration is having the unit mole per liter whole power N. So this simplifies to mole per liter whole power 1 minus N second power minus 1. Mole per liter is also called molarity. So the equation can be simplified as molar power 1 minus N second power minus 1. Or here you can remove this bracket and this gives the form mole power 1 minus N liter power N minus 1 second power minus 1. So this is the unit of an nth order reaction. So here you can see that the rate constant depends on the value of n, the order of the reaction. When order of the reaction changes, the unit of rate constant also will change. For zero order reactions, put n is equal to 0. Then you will get mole liter power minus 1 second power minus 1, which is same as that of rate. This was once asked for the Kerala entrance examination. So they have given a very long equation and the K values are also given and asked to find out the order of the reaction. Here the data given is not at all important. Only thing that you have to see is you look at the unit of rate constant. And in the case of zero order reactions, rate and rate constant will have the same unit, namely mole per liter per second. For a first order reaction, the unit is mole power 1 minus 1, that becomes equal to 0. That is mole power 1 minus 1, that is equal to 0. Then liter power 1 minus 1, that also becomes equal to 0, that is 1. So the final unit will be second power minus 1. There is no unit for concentration in the K value. Then for second order, it will be mole power 1 minus 2. That is mole power minus 1. Then liter power 2 minus 1. That is liter per second. For third order, it will be mole power minus 2, liter power 2, second power minus 2. For fourth order, it will be mole power minus 3, liter power 3, second power minus 1. So second power minus 1 or time power minus 1 is coming in all the units. Okay. So by looking at the unit of K value, you can understand what the order of the reaction is. Or to present it in another way, the unit of K depends on the order of the reaction. So you cannot write the unit of K without knowing what the order of the reaction is. Calculate the unit of rate constant for the rate law R is equal to K into CH3CHO power 3 by 2. Here K is equal to R by CH3CHO power 3 by 2. And this will be equal to R. The unit is mole per liter per second. Then concentration unit is mole per liter power 3 by 2. So this gives mole per liter whole power 1 minus 3 by 2 second power minus 1. And on simplification you will get mole power minus 1 by 2 liter power 1 by 2 second power minus 1. So this is the unit of a reaction where the order is 3 by 2. Now let us see the difference between rate and rate constant. The first difference is rate is the change in concentration with respect to time, whereas rate constant is the rate when concentration is unity. The most important thing is rate depends on concentration, temperature, pressure, nature of the reactants, etc. While the rate constant is a constant and depends only on temperature. Concentration, pressure, nature of the reactant, etc. has no effect on the value of rate constant. Then rate changes with time. Rate constant will not change with time. Then rate has a fixed unit, mole per liter per time, and this do not depend upon the order. Just now we have seen the unit of rate constant depends on the order. Different order reactions will have different value for the unit of rate constant.